Hello ladies and gentlemen, today we're going to talk about what is on the Chapter 12 test. The Chapter 12 test will be Monday, March 12th. Section 1, state whether each number is rational or irrational. Rational numbers, they are your repeating decimals or they terminate. So we're talking either a terminating decimal or a number that doesn't even have a decimal at all. 0.8 repeating, because it repeats, it is a rational number. 8 terminates, it is rational. The square root of 36 is 6, so it is rational. Radical 10, remember that when you have radicals you cannot take the square root of. They are irrational numbers. They do not terminate. They do not repeat. Radical 10 is irrational. For the last one here, I'm suspicious. I can take square roots of decimals when they have even number of decimal places, and you got 0.24 here. So there's a good chance that that's not really holding you back. So what I'm going to do is I'm going to actually compute this on the calculator and see if it terminates. This turns out to be 6.8. So even though the decimal might make you think, well, I can't take the square root of that, it turns out that you can, and that's a rational number. Roman numeral 2 here, expressed in simplest radical form. This is simplifying radicals, which is a huge part of this chapter. Perfect square that goes into 50 is 25. 50 is 25 times 2. When I take the square root of 25, the radical sign goes away. And 3 times 5 is 15, so that's 15 radical 2. Here, the largest perfect square that goes into 32 is 16. That's 16 times 2 is 32. Half of 16 is 4. And then 1/2 times 4 is 2. So this is 2 radical 2. Box these answers up. 49x cubed y. This is 49x squared radical xy. I can take the square root of 49x squared, so I'm going to go ahead and do that. I cannot take the square root of xy, so I will not do that. And that's the final answer. Okay, we're going to perform basic operations now. Remember, if you need to, you can rewrite this problem as 7 radical 2 minus 1 radical 2. Because we have like radicals, I can subtract the coefficients. This is 6 radical 2. In problem 2, before I get rolling here, I have to get a common radicand. 27 is 9 times 3, so that reduces to be 3 radical 3. 75 is 25 times 3, so that's radical 25 radical 3 there. Take the square root of 25. And then I'm going to add the coefficients together, so this gives you 8 radical 3. Over here, I do have a hint. Hint, hint, the radical 3 is a hint. This becomes 2 radical 4 radical 3, which is 2 times 2 radical 3, or 4 radical 3. So 2 radical 12 reduces to 4 radical 3. Radical 48 is radical 16 times radical 3, which is 4 radical 3. And I'll just bring that down to the next step so everything's lined up nicely. Please notice that's negative. So I have a positive 4 radical 3 and a negative 4 radical 3. And then I'm adding the little 1 radical 3 at the end. So 4 minus 4 is 0, plus 1 gives you 1 radical 3 as the answer. We cannot add or subtract radicals unless they have the same radicand, so we have to simplify when that's the case. Alright, well, 16 goes into 32. A squared is a perfect square, so I'll put it there. What's left over is the 2. This is 3 times 4a, radical 2, or 12a, radical 2. For 18a squared, I'm going to break that up into radical 9a squared and radical 2. The square root of 9a squared is 3a. And I'll just bring that down so everything lines up. 12 plus 3 is 15. 15a radical 2. Alright, now we're multiplying. Remember the rules for multiplying. We multiply the coefficients together, and then we multiply the radicands together. the coefficients stays a coefficient, or the product stays a product, or let me start over there. The product of the coefficients remains a coefficient. The product of the radicands remains a radicand. If necessary, you reduce what's left over. So 30 radical 2. 6. What I recommend here is rewriting the problem. This is 3 radical 4 times 3 radical 4. We multiply the coefficients. We multiply the radicands. The product of the coefficients remains a coefficient. The product of the radicands remains a radicand. Since 16 is a perfect square, I'm going to take the square root. And then the final answer to this problem is 36. Problem 7. We have division now. We divide the coefficients. That quotient will remain a coefficient. The coefficients are 1, so we don't have to do that. We're going to divide the radicands. That quotient will remain a radicand. And then if possible, you reduce your final answer. So that's 2 radical 3. For problem 8, we divide the coefficients. That quotient is going to remain a coefficient. We divide the radicands. That quotient is going to remain a radicand. So we get 4 radical 18, which is 4 times radical 9 times radical 2. That's 4 times 3 radical 2, which is 12 radical 2. Now, there's a problem just like this on the chapter test, so you need to take the time to figure this out. Find the perimeter in simplest radical form. Remember, the perimeter is found by adding the sides together, and because this is a rectangle, this side is 4 radical 6, this side is 5 radical 3. So I'm going to take the sides 4 radical 6, 5 radical 3, 4 radical 6, 5 radical 3. I'm going to add them together. 4 radical 6 plus 4 radical 6 is 8 radical 6. 5 radical 3 plus 5 radical 3 is 10 radical 3. 8 radical 6 and 10 radical 3 are not like terms, so don't cram them together, turning them into something that it is not. You could also use P equals 2L plus 2W, which would make the problem just a tiniest bit shorter. Alright, give perimeter to 4 significant digits. If I take this solution, 8 radical 6, close that parenthesis up, plus 10 radical 3, close that parenthesis up, I'm going to get 36.916, etc. 4 significant digits, 36.92. 36.92. Area. Well, area of a rectangle is length times width. Area is length times width. So I'm going to take 4 radical 6 and 5 radical 3 and multiply them together. This gives you 4 times 5 and then radical 6 times 3, which is 20 radical 18. Reduce radical 18. Might be able to do this one in your head by now. You've done radical 18 quite a few times. And you get 30 radical 2. Now, which side is longer? Take our calculator, compute 4 radical 6, 9.79, etc. Take 5 radical 3. Which one's the bigger number? It appears that 4 radical 6 is the bigger number. So we would say 4 radical 6. This completes the review for the chapter, give you a quick overview of what's on the test. Tomorrow we're going to work on page 497, 3 through 40, all in class. There will not be, well, I'm sorry, that's mistaken. There will be a quiz on multiplying and dividing radicals, multiplying and dividing, so please look that over. I look forward to seeing you tomorrow. Have a good evening.